The National Electrical Code, specifically Section 210.12b, addresses the requirements for arc fault circuit interrupter, or FSI, protection in dwelling units. This section is crucial for ensuring electrical safety and preventing fires caused by arc faults. Arc faults are unintentional electrical discharges that can occur in a wiring system. They generate intense heat and can ignite surrounding materials, leading to a fire. Section 210.12b mandates that all 120-volt, single-phase, 15 and 20-ampere branch circuits that supply outlets or devices installed in dwelling unit bedrooms must be protected by an arc fault circuit interrupter. This requirement aims to safeguard occupants from the dangers of electrical fires within the sleeping areas of their homes. Now, let's consider the scenario of a master bathroom that is directly accessible from a bedroom without a door, effectively forming an open archway between the two spaces. The question arises whether this bathroom should be considered an extension of the bedroom and, consequently, subject to the same arc fault protection requirements. In this specific situation, the master bathroom would indeed be considered an extension of the bedroom. The absence of a door separating the two spaces creates a continuous living area, functionally integrating the bathroom into the bedroom. Since the bathroom is an extension of the bedroom, it falls under the purview of NEC Section 210.12b. As such, all 120-volt, single-phase, 15 and 20-ampere branch circuits supplying outlets or devices in the bathroom must be arc fault protected. It is important to note the exceptions to the arc fault protection rule. Generally, outlets installed in bathrooms and kitchens are not required to have arc fault protection. This exception typically applies to standalone bathrooms or kitchens that are distinctly separate from bedrooms or other living areas. However, in the case of a master bathroom directly connected to a bedroom without a door, the exception does not apply. The code interprets the bathroom as part of the bedroom, eliminating the exemption. Therefore, the entire circuit, including the portion serving the bathroom, must be protected by an arc fault circuit interrupter. The rationale behind this interpretation lies in the intent of the code to provide comprehensive fire safety for sleeping areas. Bedrooms are considered high-risk areas because occupants are often asleep and less likely to detect a fire early on. By extending the arc fault protection requirement to connected bathrooms, the code aims to minimize the risk of electrical fires originating in these adjacent spaces. Installing arc fault circuit interrupters involves replacing standard circuit breakers with FSI breakers in the electrical panel. These breakers are designed to detect the unique characteristics of arc faults and quickly interrupt the circuit, preventing the arc fault from escalating into a fire. When selecting an FSI breaker, it is essential to choose one that is compatible with the type of wiring system used in the dwelling unit. There are several types of FSI breakers available, including branch/feeder FSI breakers, combination FSI breakers, and outlet branch circuit FSI breakers. Choice of FSI breaker will depend on the specific wiring configuration and the requirements of the local electrical code. Proper installation of FSI breakers is crucial for ensuring their effectiveness. It is recommended to have a qualified electrician install the breakers to ensure that they are correctly wired and functioning properly. Regular testing of FSI breakers is also important to verify that they are providing the intended protection. FSI breakers typically have a test button that can be used to simulate an arc fault and verify that the breaker trips as expected. The National Electrical Code is a comprehensive set of standards that governs the safe installation and maintenance of electrical systems. It is updated every 3 years to reflect the latest technological advancements and safety practices. Compliance with the NEC is essential for ensuring the safety of occupants and preventing electrical fires. In summary, when a master bathroom is directly accessible from a bedroom without a door, it is considered an extension of the bedroom and must be protected by arc fault circuit interrupters. This requirement is in accordance with NEC Section 210.12b and aims to provide comprehensive fire safety for sleeping areas. Installing and maintaining FSI breakers is a critical step in preventing electrical fires and protecting occupants from harm. It is also vital to remain up to date with any changes to the NEC requirements to ensure continued compliance and safety. It's crucial to understand the specific nuances of the electrical code as they apply to different situations. The NEC is not always straightforward, and interpretations can vary. That is why consulting with a licensed electrician or electrical inspector is always a good idea, particularly when dealing with complex wiring configurations or ambiguous code requirements. In the case of the open concept bedroom and bathroom, the primary concern is the continuous and obstructed airflow between the two spaces. This lack of separation means that any potential fire hazard in the bathroom, even if minor, could quickly spread to the bedroom, where occupants are often asleep. The FSI protection serves as an additional layer of safety, mitigating the risk of electrical fires that might otherwise go undetected until it is too late. Consider a scenario where a faulty hair dryer in the bathroom develops an arc fault. Without FSI protection, the arc fault could continue to generate heat, potentially igniting flammable materials such as towels, rugs, or toiletries. The resulting fire could quickly spread to the bedroom, endangering the occupants. With FSI protection, the arc fault would be detected by the breaker, which would immediately trip, cutting off the power to the circuit and preventing the fire from starting. The FSI breaker's ability to detect and interrupt arc faults is based on sophisticated electronic circuitry that monitors the current flowing through the circuit. Arc faults produce unique current signatures that are different from normal operating conditions. The FSI breaker is designed to recognize these signatures and trip the circuit when they are detected. It is important to distinguish between arc fault circuit interrupters and ground fault circuit interrupters, or GFCIs. While both devices are designed to protect against electrical hazards, they operate on different principles and provide different types of protection. Ground fault circuit interrupters protect against electrical shock by detecting imbalances in the current flowing through the hot and neutral conductors. If a person comes into contact with a live wire and provides a path to ground, the GFCI will trip, cutting off the power and preventing a potentially fatal shock. Arc fault circuit interrupters, on the other hand, protect against electrical fires by detecting arc faults. Arc faults do not necessarily involve a path to ground, so a GFCI will not typically trip in response to an arc fault. However, some FSI breakers also incorporate GFCI protection, providing both fire and shock protection in a single device. These combination FSI/GFCI breakers are often used in locations where both types of protection are required, such as bathrooms and kitchens. In addition to the specific requirements of NEC Section 210.12b, there may be other applicable code requirements that need to be considered when wiring a bedroom and bathroom. For example, NEC Section 210.8 requires GFCI protection for all 125-volt, 15 and 20 ampere receptacles installed in bathrooms. This requirement is intended to protect against electrical shock hazards associated with wet environments. Furthermore, NEC Section 404.2c requires that switches controlling lighting fixtures in bathrooms be located so that they cannot be reached by a person using a bathtub or shower. This requirement is intended to prevent accidental contact with live electrical parts while the body is wet. When planning the electrical wiring for a bedroom and bathroom, it is essential to consult with a qualified electrician or electrical inspector to ensure that all applicable code requirements are met. Failure to comply with the NEC can result in serious safety hazards, including electrical fires and shocks. It is also important to consider the future needs of the occupants when designing the electrical system. Providing adequate outlets and circuits can prevent the need for extension cords and power strips, which can be a fire hazard. Installing energy-efficient lighting fixtures and appliances can also help to reduce energy consumption and save money on electricity bills. Moreover, consider the placement of electrical outlets and switches. Outlets should be conveniently located for plugging in lamps, electronics, and other devices. Switches should be easily accessible for turning lights on and off. The height of the outlets and switches should also be considered, especially for individuals with disabilities. The Americans with Disabilities Act, or ADA, provides guidelines for the placement of electrical outlets and switches in accessible spaces. The ADA requires that outlets and switches be located no higher than 48 inches and no lower than 15 inches above the finished floor. This ensures that they can be easily reached by individuals in wheelchairs or with limited mobility. The electrical system is a critical component of any dwelling unit. Proper design, installation, and maintenance of the electrical system are essential for ensuring the safety and well-being of occupants. By following the requirements of the National Electrical Code and consulting with qualified professionals, it is possible to create a safe and reliable electrical system that meets the needs of the occupants for years to come. Remember that electrical work can be dangerous. Always turn off the power to the circuit before working on any electrical components. If you are not comfortable working with electricity, hire a qualified electrician. It is always better to be safe than sorry when it comes to electrical work. The specific application of the NEC to the scenario underscores the importance of understanding the code's intent. The code aims to provide a minimum standard of safety, and its interpretation often relies on the specific context of the installation. In this case, the open connection between the bedroom and bathroom effectively blurs the lines between the two spaces, leading to the determination that the bathroom should be treated as part of the bedroom for F-SAI protection purposes. This highlights the need for a flexible and adaptable approach to code interpretation, taking into account the unique characteristics of each installation. It is also important to consider the potential for future modifications to the dwelling unit. If the homeowner were to later install a door between the bedroom and bathroom, the requirement for F-SAI protection in the bathroom might be reconsidered. However, it is generally advisable to err on the side of safety and maintain the F-SAI protection, even if it is not strictly required by the code. The cost of installing and maintaining F-SAI breakers is relatively low compared to the potential cost of an electrical fire. In addition to the direct financial costs, there are also the emotional and psychological costs associated with a fire, which can be devastating. By investing in F-SAI protection, homeowners can provide peace of mind and protect their families from the dangers of electrical fires. Furthermore, the use of arc fault circuit interrupters is not limited to bedrooms and bathrooms. The NEC also requires F-SAI protection in other areas of the dwelling unit, such as family rooms, living rooms, dining rooms, and hallways. The specific requirements vary depending on the edition of the NEC and the local amendments that have been adopted. It is important to consult the applicable code to determine the specific requirements for each area of the dwelling unit. As technology advances, new types of F-SAI breakers are being developed that offer enhanced protection against electrical fires. These new breakers are able to detect a wider range of arc fault signatures and provide more precise and reliable protection. They also incorporate features such as self-testing and remote monitoring, which can help to ensure that the breakers are functioning properly. The future of electrical safety is likely to involve even more sophisticated arc fault detection and prevention technologies. These technologies will help to reduce the risk of electrical fires and protect occupants from harm. In the meantime, it is important to continue to follow the requirements of the National Electrical Code and consult with qualified professionals to ensure that electrical systems are installed and maintained safely. Remember, electrical safety is everyone's responsibility. By taking the necessary precautions, it is possible to prevent electrical fires and protect lives.